Assalamualaikum and hi. My name is Muhammad Ali Faikal bin Ridzuan, matrix number AF190020. Now, I will explain about the introduction of our group projects. In our project, we have chosen Kelantan as our study site. To be precise, Pasir Mas, Kelantan is the district that has been chosen to be in our project. For the rainfall stations, we have chosen Rumah Pamrepek, Kampung Tandak Rainfall Station, and also Bukit Kuan Dam. The reason for us to choose the state of Kelantan as our study site is because floods is often occur in the Pasir Mas district. Because of that, we would like to take the opportunity to study the rainfall in the area.
My name is Amirul Aiman bin Amir, number matrix AF190097. I'll be presenting methodology and mean area rainfall results. According to our flowchart, first, we choose location for our project, which is Rantau Panjang, Kelantan. Next, we choose rainfall and water level station, which is 3 station and 1 station respectively. And then we go through data collection, which data is collected for 32 days. And lastly, we go through data analysis. We use 3 methods to calculate the results. First, arithmetic mean method. Second, Thiessen polygon method. And third, isohydral method. For arithmetic mean method, the data we calculated is 225.55 mm. For Thiessen polygon method, the data we obtain is 222.03 mm. For isohydral method, the data we gain is 238.47 mm.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Murkemi, and I will explain about the unit hydrograph. Okay, as we can see in from the graph cross section 1 of Q1 total flow against time, we can calculate the total direct runoff volume equals to 12.151 meter cube per second, and equivalent runoff depth equals to 0.00875 meter. Okay, from the graph cross section 2 of Q total flow against time, we can calculate the total direct runoff volume equals to 1.826 times 10 to the power of 6 meter cube per second, and equivalent runoff depth equals to 0.365 meter. Okay, for the unit hydrograph for cross section 3, we can calculate the total direct runoff volume equals to 1.103 times 10 to the power of 6 meter cube per second, and equivalent runoff depth equals to 0.221 meter.
Assalamualaikum and hi, my name is Abdul Aziz bin Ahmad Kamal with matrix number AF190122. Now I will proceed to the calculation of the peak flow and discharge of the river. Basically, the peak discharge is the time when the river reaches its highest flow. There is a delay because it takes time for the water to find its way to the river. This is called as lag time. The base flow of the river starts to rise when runoff, ground and soil water reaches the river. In this part, we use formula for peak flow according to MSMA second edition, which is Q equal to C multiplied with I multiplied with A divided by 360. And this formula also known as rational method. And for each symbol, let's say C represent as runoff coefficient, I represent as average rainfall intensity, and lastly A represent as area of the watershed. These are the value of the discharge water Q that we obtain for each section, section 1, 2 and 3. The formula of the discharge water Q is Q equal to AV. So, to get V, we must use many equations from area 1 to area 10. That is 1 over roughness coefficient multiplied with the hydraulic radius R with the power of 2 over 3 multiply with the water surface slope S with the power of 1 over 2. As a result, for the cross-section 1, we get R equal to 0.919 meter. Gradient slope, we get 1.333. The flow rate of discharge water V, we get 8.732 meter per second. And after we multiply, we get Q equal to 1.992 multiply with 10 with the power of 3 meter cubic per second. That is for the cross section 1. And we repeat the same step for the cross section 2 and we get the R value is 0.928 meter. Flow rate of discharge water V 9.486 meter per second. And Q equal to 2.264 multiply with 10 with the power of 3 meter cubic per second. And lastly, for the cross section 3, we get R is equal 1.219 meter, V equal to 9.486 meter per second, and the Q we get 2.264 multiply with the 10 power of 3 meter cubic per second.
For the conclusion, it should be noted that the discussion in this report cover both the study and research on the technique used. Each method has advantage and disadvantage, but factors such as accurate data loss calculation, errors, and the site chosen must all be considered. Furthermore, improvement to this method has been proposed. It is critical to reduce errors and make the process more efficient. That's all from us. Thank you.